The cell has something called a plasma membrane. This membrane is going to protect the cell and keep it contained from the outside world, but the cell membrane in itself is also going to allow the cell to communicate and traffic incoming and outgoing events to the outside world. So it's a nice little spot for that. The plasma membrane is known as a semi-permeable phospholipid bilayer. So that's just a really nice fancy way to really describe what the membrane is. Let me go ahead and dissect that for you. So it's semi-permeable because it only allows certain molecules and substances to go through it. So it allows some, so that gives it permeability, but it's semi-permeable because it doesn't allow everything. Phospholipid is next to the name because phospholipid is the components that make up the plasma membrane. Check it out. So here I have boxed a single phospholipid. It has that gray, what's now in pink here, hydrophilic head. I'll go over that. And it also has these yellow tails. These are hydrophobic tails. So the head of a phospholipid is actually hydrophilic, meaning it's water loving. It has to do with the polar nature of the head, the chemical nature of it. It actually very much does enjoy being around water, but the tails of the phospholipid, there's actually two tails there, they're hydrophobic because they're lipids. Remember I taught you that lipids are water fearing. They don't want to be around water. So this is important because these tails that are afraid of water are going to hide away from water, but the heads don't mind being around that environment. Well, the outside of the cell is very much water, and so these heads are located by it. The tails hide away. Well, on the other side, the inside of the cell is also composed of lots of water, the cytoplasm, as we'll go over, so those tails hide away from it. So we can actually see how they kind of reverse to where the tails are located on the inside of the membrane with those hydrophilic heads forming the membrane as well. This gives us now the bilayer, 2 layers of phospholipids in order to compose that membrane. Those hydrophilic heads being found on both the outside and the inside, kind of watery components, those hydrophobic tails hiding away, shying away, forming the inside of that membrane. The cell membrane wouldn't be what it is without these hydrophilic and hydrophobic components of phospholipids. So the cell membrane is also known as a fluid mosaic model. Fluid because of its nature. We can see that movement that we're seeing there with that phospholipid bilayer. It's very fluid, and it's mosaic for the point that there's a diversity of proteins, carbohydrates, and lipids that are actually embedded in the cell membrane. It's not just phospholipids that we find. It's a number of different molecules that are going to contribute to traffic and communication of the cell.